this is problem number 4 of the tear-off. Part A, they give us the function f of x equals 1 over x minus 2, and they say use limit definition to find the derivative. So you have to make sure that you show the limit definition and you just don't find the derivative, otherwise you won't get points. So we need to use limit definition. Okay? So the limit definition is going to be the limit as h approaches 0 of f of x plus h minus f of x over h, and that will equal f prime of x, the derivative. So we're just going to plug x plus h in every time we see x, and then x in every time that we see x. So we have the limit as h approaches 0 of 1 over x plus h minus 2 minus 1 over x minus 2 all over h. So we have to get a common denominator. It's just simplifying from here. So I times this one by x plus h minus 2 over x plus h minus 2. And I times this one by x minus 2 over x minus 2. Okay? So I get the limit as h approaches 0 of x minus 2 minus x plus h minus 2 all over x minus 2 times x plus h minus 2 times 1 over h. So we can multiply by the reciprocal. Now I simplify. I get the limit as h approaches 0. My x's cancel and my 2's cancel. Negative 2 minus negative 2 is plus. So I get minus h over x minus 2 x plus h minus 2 times h. So my h's cancel. So I get the limit as h approaches 0 of negative 1 over x minus 2 x plus h minus 2. And now as h goes to 0, this term goes to 0. So I get negative 1 over x minus 2 times x minus 2, and then that's negative 1 over x minus 2 squared. Okay? So they want to see that you can use the limit definition. So the limit definition will be the limit as h approaches 0 of f of x plus h minus f of x over h equals the derivative of f of x. So we plug in x plus h every time we see x, and we get 1 over x plus h minus 2 minus 1 over x minus 2 over h. And then you have to get a common denominator. So we multiply this side by the opposite in this one. Then once I have my common denominator, a lot of terms will end up canceling out, and then your h's cancel, and now we take the limit as h goes to 0, and we get this, and that's our final answer. And if you can find the quotient rule quickly, you can check your answer there. So part B says to write the equation of the tangent line at x equals 3. So remember, the slope of the tangent line equals the derivative. And we need a slope and we need a point to find the line. Okay? So we're trying to find the tangent line. You know you need a slope and you need a point. So we have our f prime of x equals negative 1 over x minus 2 squared. So f prime of 3 will be negative 1 over 3 minus 2 squared, which is negative 1, and that's my slope. Okay? So now I need a point. I'm going to use my original equation. So f of 3 is 1 over 3 minus 2, which is 1. And that's going to be my y value. So my point will be 3, 1. So now that I have a slope and I have a point, I can write it in slope-intercept form. So we know that y equals mx plus b. So I say that 1 equals negative 1 times 3 plus b. So 1 equals negative 3 plus b. b equals 4. So my equation is y equals negative x plus have to write an equation of a line. That means we need a slope and we need a point. Our slope of our tangent line is going to be the derivative, so we already found the derivative of our function, and then we plug in 3 because it says that x equals 3 and we get our slope -1. Now to find a point, we plug 3 back into our original equation and we get that y is 1, so we have the point 3, 1. Then we write it in y equals mx plus b form and we have an equation of the tangent line. And then part C says to sketch f of x and its tangent line and show the y-intercept of the line. So let's do that. So part C is graphing, and I'm just going to do a rough sketch. So first we're going to graph 1 over x minus 2, and we know that that's going to have a vertical asymptote at x equals 2. Okay? And it's a reciprocal function, so remember the parent function is going to be here and here. Okay? So this is y equals 1 over minus 2. And now we just need to graph the tangent line. It wants us to show when it intercepts the y-axis, and it intercepts the y-axis when x is 0. When x is 0, we get 4. So we have 1, 2, 3, 4. And we also know that we have the point 3, 1 on our line. So we have 1, 2, 3, and then up 1 is also a point. So our tangent line is going to come through and cross and go down. Okay? And this point is 0, 4, which is our intercept. Okay, so they just want us to sketch the graph of f of x and its tangent line. So f of x will be the reciprocal function shifted to the right 2 units, so the new y-intercept is at x equals 2. And then our tangent line, remember our tangent line can cross the vertical asymptote because it's not a vertical asymptote of the line, it's a vertical asymptote of the function. So it's going to cross. They wanted us to show the y-intercept, which is 0, 4, because when x is 0, y is 4, and then it touches at the point 3, 1 right here. Okay? So that's the graph of f of x and its tangent line, and this is number 4.